Good afternoon. I am Renu Sharma, Assistant Professor EC Department. Today I am going to start with the next part of this subject, that is data communication network, and today's topic is network delivery, then forwarding and routing, part 1. So, the contents of this lecture are: first one is delivery of the packets, how the data is delivered through a network. If there are two networks which are connected through connecting devices such as router, gateway or anything, so how the data will be delivered. Then forwarding, how the data will be forwarded using routing tables, means at the router, if it is used as a connecting device, then certain tables are maintained at the router which consist of source address, destination address and other additional information. So, that data will be forwarded from that particular network to another network. So, this is the first topic, that is delivery. The network layer supervises the handling of the packets by the underlying physical networks. We define this handling as the delivery of a packet. So, basically we are discussing the OSI model once again, and how the packets will be formed, how these packets will travel over the different layers of the OSI model. Once again I am going to summarize the different layers of the OSI model. So, this ISO OSI model will consist of 7 layers. Basically, these layers are: first one is the physical layer, then data link layer is there, network layer, transport layer, session, presentation and application. So, basically there are 7 layers which is responsible for transferring the data in a layered architecture. In the layered form the data will be transferred, and these same layers will be used at the transmitter side as well as the receiver side. So, this is the concept behind the layered architecture. So, in this delivery, if you can see that the network layer supervises the handling of the packet by underlying physical networks, which means the main role of the network layer is to handle the packets for the network that is underlying the particular network layer. So, that is the main concept behind this today's lecture, how the packets will be handled, how these are delivered at a particular different step of the next step of the layer. So, this is the main focus of today's lecture. So, first we will see that what is direct delivery and what is indirect delivery. As you can see that in this case, first diagram is showing this direct delivery. In case of this direct delivery, you can see that this is host 1, this is host 2 and this is connected to a network. Now, this network can be a ATM network, that is a frame relay network. In my previous lecture, I have discussed about the frame relay and ATM, that is the asynchronous transfer mode. In case of frame relay, there are crossbar switches which are used to connect a network, and that is strictly based on the virtual that is virtual circuit connected network. So, this is virtual circuit network which is connected through crossbar switches. So, inside this network there are different crossbar switches which are placed at different layer at different locations, and whatever path is being decided between the two hosts, these crossbar switches will be connected for that transmission mode. So, that is the concept of this virtual circuit network. So, this is host A, this is host B, which means this is transmitter and this is receiver. So, in this case, what do you mean what is meant by this direct delivery, that there is no intermediate node is there between this host and this host. You can directly transfer the data without the use of any router or any intermediate host may be also possible. So, in case of direct delivery, this is a kind of point to point communication. You can see a point to point protocol will be followed between the host A and host B. Same is the case if I want to deliver the data from this host to direct deliver from this host to this router. This is basically a router, or from router to this host. So, this is also the way where the data will be transferred from this router to this host. So, this is a case of direct delivery where there is no intermediate node exist between the two computers or two router or a different computers. So, that is the case for direct delivery. Now, the second case is the indirect and direct delivery. So, in this diagram if you can see that it consists of it explains both the concept of indirect delivery as well as the direct delivery. As in this case, in this indirect delivery you can see that this host will act as a source, this host is acting as a destination, this is the router, this is the intermediate node. So, if somehow if I want to transmit the data from this point to this point, then it has to follow through this router, through this network. So, this will act as a intermediate node for transferring the data from here to here. So, that is not directly connected. So, this means this is a indirect delivery case, but when we are considering the data to be delivered from without any effect of any intermediate node, like from this point to this point. So, that is the case for direct delivery sense. So, this is nothing, this is the direct delivery case. So, that is how the data will be transferred from this router to this host destination. So, this diagram is showing both the indirect case when we want to transmit the data from here to here. So, that will be followed through this router, and if I want to transfer the data from this router to host, or as a second case is also available, if I want to transfer the data from this point to this point, then there is no intermediate node will going to interfere the transmission. So, that is also the case for direct delivery. So, these are the two very basic kind of the delivery options which are available. First one is direct, second one is indirect. So, next we will consider what is forwarding. Forwarding means to place the packet in its route to its destination. Forwarding requires a host or a router to have a routing table. So, basically from here onwards we are going to discuss that there are intermediate nodes like a router. So, router will not going to, router is a kind of a connecting device that maintains a routing table which consists of source address, destination address and other additional information. So, that table will be changed, or it will be varied depending on the network which is been established. So, that particular table is not fixed, you can say it is always variable in nature. So, it requires a host and the router to have a routing table. When a host has a packet to send, or when a router has received a packet to be forwarded, it looks at its table to find the route to the final destination. So, basically what is the use of that particular routing table? It consists of the, it is a kind of map, you can say. In map, when we want to visit some place, or we want to go some to place, or return to some the initial space, then we have to follow a particular map. So, that particular concept is used in the routing table, where the path is pre-decided and it is being fed into the table, and when we want to transmit the data, when we have the packet to follow to transfer to a particular destination, then it has to follow or concern that particular routing table. So, and it will change depending on the host. If the host will change, then the routing table definitely it will going to change. Now, this is the routing table which I am talking about, that route method versus the next hop method. So, what is the difference between route table and the which is based on the route? So, this is route tables based on the routes, this is route table based on the next hop. Hop means basically the jump. Let us say there are two intermediate nodes exist between the transmitter and receiver, like the example which is being shown over here. This is host A and this one is host B. So, there are two intermediate nodes are there which will be acting, or which through which the information has to be transferred. So, these informations or the path that has to be followed for delivering the data from here to here, it has to consist of two routes, that is route 1 and route 2. So, this one is the routing table which is based on the route. So, this is the destination which is host B, then the route is consisting of R1, that is router 1, this is R2 router 2, and this is the destination, which means that it has to follow the route to reach to this host B from packet A. Next one is that is having the routing table for the host A, then it has to follow the routing table here, then it has to follow a routing table here. So, routing table for R1. So, destination is host B, which the remaining path or the remaining points in this particular route is R2 and host B, because it has reached to this R1. So, this is the routing table for R1. Now, the packet has reached over here. So, what is the routing table which has to be followed at this point, so that the packet will be transferred to this host B. So, this is the route, that is host B. So, that is the source, this is the destination, there are two intermediate nodes, and at every point the routing table will going to change, update, you can say that it will going to update. So, if I reached the first intermediate node, then the routing table will change. If I reach the second second node, then the routing table again it will going to change, or you can say update. So, this is how if you can see that in this there are 3 points are there, R1, R2, host B, then it has reached to R1, then the point are R2 and host B, then it has again reached to R2, then the point will be host B. So, this is the case for the routing table. Now, this is based on route. Now, we will discuss that the routing table which are based on next hop. So, how the routing tables will be used. As you can see that the entries that are made in this table, which is based on the next hop, it consists of only the next router data that has to be hopped or it has to be jumped on. Like in case of this one, the destination is same in all the 3 entries, that is the host B. Next hop for this case is R1. This is the case. Then the next hop in this case will be the R2, and the next hop in this case, that is the destination. So, we have not added any information in this point, that is next hop. So, you can see the basic difference between these 2 points is only that the number of entries that are made in the first case and in the second case. In this case, you have to every time you have to tell the route at every point it has the packet is there, and in this case you have to just mention the next hop. So, you can say that this one second case is much simpler as the case which is used in the first one. The next one is host specific versus network specific method. So, there are 2 types of methods that can be used in the routing table. First one is the host specific, second one is the network specific. So, in case of this host specific, the major concern is there on the host only, like the routing table for host S based on the host specific method. So, this is network 1, you can see this is router 1, this is network 2, and to this there is a device which is connected, which is having 2 different types of routing tables. And at this point at the receiver side there are 4 different nodes are there, that is A, B, C and D. So, you can see that this is the destination which is A, B, C and D. So, the next hop will be R1 for all the cases. If I want to reach to A, B, C or D, then the next hop will be R1. So, this is fixed. So, I can reach after R1 to any one of the point, that is A point, that is B point, C point and D point. And in this case, that is the routing table for host S, that is based on the network specific. If I am considering the network specific, then I have to mention the destination which is N2. So, you can see that this has been replaced by N2, because all the 4 devices are connected to the second network only. So, I can consider the destination that is N2. So, in this case this is also reduced, that has been replaced by R1, because the next hop for all the 4 cases will be R1. So, this if you are going to compare these 2 entries. So, this is also the second one is much more simpler in terms of entry wise, and this is the detailed version of the information. So, this is host specific versus network specific case. Now, next one is the default method. In case of default method, what are the entries that are made? Because if I am not selecting any host specific, network specific or any kind of specific entry which has to be made in the routing table. So, there is a default method also. So, the destination is N2 or any other destination, like you can see over here, this is the network or the destination, may be here also, that is the rest of the internet, and this particular routing table is maintained here. So, this is the transmitter, you can say, or it is the source, and these two are the destination. This one is the destination, this one is the destination. So, the data will be transferred either to this side or to this side. So, destination will be N2, the next hop will be R1. If I want to reach to any other net destination, then the next hop will be R2. So, that is the case for the second one, that is the next hop, that is denoted by R2. So, this is the default method which is shown over here. So, this is the table that has been maintained for transferring the data from one point to another point with the use of only one intermediate node, and if it is not written that which particular network it has to shift it, then it can be done using this one or this one. So, this is the default method. Now, next we will move to simplified forwarding module in classless addresses. So, in the previous lecture I have discussed about classes, different types of classes are there, that is class A to class E. So, there are 4 bytes are there, like class A, then class B, class C up to class E. So, basically there are 5 different classes are there, and these 5 classes are described for IPv4 and IPv6 address, that is denoted by dotted decimal, or you can also use the hexadecimal notation, decimal or dotted decimal. In case of this one, like for class A, the first byte is described over here, then this is the second byte, then this one is the third byte, and this one is the fourth byte. So, this is the class, like this is described by 00, that this is 01, this is 001, this is 00001, and this is 4 times 0 and 1. This is just an example, I am not very rigid that this is the particular table, I am just explaining the example. So, this is a kind of class address which has been maintained, so that if a particular IPv address has been received, then you can clearly see this table, and you can clearly find out that whether it belongs to class A, whether it belongs to class B, class C, class D or class E. So, this is a simplified forwarding module. So, if I do not want to use any type of class that that particular reference table is not presented, then I can use this one. So, this is the packet which has reached to this forwarding module, this is the exact destination address, and this will consist of the search table. Now, when we have received this exact destination table, then address, then it has to reach to another search table. Now, this search table is basically this table, which is a kind of routing table only. This is a kind of routing table, and the packet has to be transferred from this point to this point. So, this is the next hop address and the interface number which is been shown over here. So, this is the search table. After the packet has been transferred to this forwarding module, then this will be transferred to this exact destination address, and it will going to search from this. So, this consists of mask, that is denoted by n. If you remember that for IPv6 we have used this type of notation, in which this is the address and this is the mask, this is the mask number. So, from here we can find out what type of mask it has used, then this is the network address, next hop address, and this is the interface. So, if any kind of interface that has been used between the two devices that is connected to a network, so that is mentioned over here. Next hop address, let us say it is router 1, router 2, so that is having their own address, so that is also mentioned in this next hop address, and this is the network address, like network 1 is having their own address, network 2 is having their own address. So, that is the case for simplified forwarding module. So, this is how the particular data will be there. Then this is to ARP, that is the automatic request protocol that has been used. If the particular packet is not received correctly at the receiver side, then that request has to be sent to the receiver that yes, please send that particular packet again. So, that is the automatic repeat request protocol. So, this is a simplified version forwarding module in the classless address when we are not strictly concerning the classes that are being used. Next one is make a routing table for router R1. So, this is the router R1 using the configuration that is used in a figure. So, this is a example that I have taken just to show you that how this particular address will be maintained. If you can see that this is written as 201 dot, this is dotted decimal notation 24. So, this is x dot y dot z dot t by n. So, this is nothing, it is the mask and this is the address. So, if you can see that this is router 1 R1, this is router 2, these are having their own addresses, and it as you can see that if I move from here, then it will be appended from 192 to 200 and the rest of the address will remain same. So, that is the difference, that how the particular address will be appended, means it will be changed, updated. So, I have to create a routing table using this data. So, we will see that how the routing table will be maintained. So, as you can see that these are the different masks which are used over here, that is by 26, by 25, by 24, then by 22. So, these are the different masks that are considered over here. These are the network addresses. If you can see in the previous slide also that this is by 22, by 25, by 24 and by 26. So, these are the 4 different entries which are made, and if it is moved to the rest of the internet, then different mask will be available, and these are the addresses which are mentioned in the table. So, you can see over here, this is these are the different masks, these are the address corresponding to these masks. This is showing the next hop information, and this is showing the interface which is been written over here, that is M2, M0, M3 and M1. So, these are the interfaces which are going to connect the different devices to the center network. So, this is how we have to maintain a routing table. So, this is nothing, this is an example of how to create a routing table depending on the network that has been given to you, that consists of the address, that consists of the mask information, and it also consists of the next hop information. Now, this is the second example, that to show the forwarding process if a packet arrives at R1 in figure 2 with the destination address this one. So, in this question we have to first show the forwarding procedure if a particular packet has arrived at router R1 and with a destination address which is written over here 118.24.32.78. So, this is the destination address. So, this time all the masks are applied one by one to the destination address, but no matching network address is found. So, when it reaches the end of the table, the module gives the next hop address that is written over here, and the interface number which is M2 to ARP. So, M2 is basically the intermediate node and ARP is the automatic repeat request protocol. So, this is probably an outgoing package that needs to be sent via default router to some place else in the internet. So, basically in this diagram, as you can see that certain masks are fixed, that is by 22, 24, 25 and 26, these masks are fixed. In this question there is no mask is given, only the destination address is provided that has been reached at a particular router, and we have to forward that packet. So, it will not going to match. So, we have to find out when it reaches the end of the table, then a default next hop address will be provided, like you can see over here, and it will going to reach to ARP. So, this is the figure you can see, this is organization 1, organization 2, 3 and 4, these are the intermediate nodes or the packets to which the data has been forwarded. This is router 1, this is router 1, and somewhere in the internet, because it has to search, the destination is specifically not mentioned in this circuit, that which destination it has to reach. It may be somewhere present in the rest of the internet only. So, when it reaches to end of the routing table, then it will be forwarded to this address. Then this is the mask, as you can see that this is by 26 and we have used over here, that is by 24. So, this is the network address, this is the next hop address, and this is the interface which is been presented over here, that is denoted by M0 and M1. So, the basic difference between the first numerical and the second one is depending on the application. In the first one we have to design a routing table depending on the network which is given over here, and then the second numerical, a packet has been received and concerning the particular routing table we have to route that address, that packet to a destination address, and that address is not mentioned in any of the networks. So, it has to be delivered to ARP, that is automatic request protocol, and it has to search the basic mark. So, in this lecture we have discussed about framing and how the delivery of the packets will be there, that is the indirect delivery and the direct delivery. These are the references that you can consider for transferring the packet from one particular point to another point. So, thank you.